Hi, this is Professor David Farina. In today's lecture, we're going to be discussing the Jovian planets, the atmospheres of Jovian planets. Let's get started. When looking at Jovian atmospheres, Jupiter is probably the most easily discussed planetary atmosphere because of its dramatic zones and belts. The zones of Jupiter's atmosphere, as seen in this image, are much higher and cooler than the low-lying, darker belts. The motion of Jupiter's atmosphere can be determined based on the convection cell model. As the higher clouds are rising, the zones in other words, the belts or lower clouds are falling. So you're basically looking towards a deeper place in the atmosphere as the belts are moving downward and the zones are moving upward. You'll notice also that the motion of the zones and belts are in opposite directions of one another. So if the belt is moving in this direction, zones are moving in the opposite direction. So when we're looking at these different planetary atmospheres, the boundaries of these zones and belts are of dramatic interest because they are the areas where storm systems are able to take hold. When looking at the Jupiter atmosphere in cross-section, we can see the composition of the atmosphere and its relative temperatures change with height. So if we were to go down to this place, which is at an altitude what we would consider kind of below that visual haze layer that we see, we have our temperatures being relatively warm. So we're in the 400 Kelvin range. As we go up towards higher altitudes, more towards the top haze layer, temperatures are decreasing with height, and then they increase with height slowly again as we move into the planet's stratosphere. Now, there are various different layers of clouds as we move on up. You can see there's a water ice layer right about here, below the 100, about negative 80 kilometers below the top haze layer. There's an ammonium hydrosulfide ice layer. There's an ammonium ice layer, and these represent the bands and zones. And here's the troposphere of the planet, a haze layer, and then the stratosphere. Now, we know most of the things that we know about Jupiter's atmosphere by the Galileo probe, which was plunged towards this planet and took data as it entered. One of the most dramatic of the planetary storm systems is the Great Red Spot, as seen in this image. With Earth drawn to scale, you can see that the Great Red Spot here is almost twice the size of the planet Earth. This is caused as we've got the direction of gas flow in this direction and a shearing force from the other direction. And this causes this counterclockwise rotation, and the Great Red Spot is in motion. Now, over time, we've found that the Great Red Spot has been changing, and you can see in this image sequence that as we go from 1995 through 2014, the surface features around the Great Red Spot have been changing, and as we enter into 2019, we are seeing some dramatic changes in the Great Red Spot with the elimination of this white circle around the Great Red Spot growing smaller and smaller each day. And it's possible we're going to start to see the indications of the Great Red Spot disappearing over time, but that information is still to come. As we move on to Saturn, we find that the atmosphere of Saturn is very similar to that of Jupiter's, but it is somewhat colder, given that Saturn is about twice the distance from the Sun than Jupiter is. Its atmosphere is thicker, and it's also got fainter bands. The atmosphere of Saturn is once again very similar to Jupiter in cross-section as well. As we go down below this top haze layer, we find that there is a water ice layer. The temperatures once again are relatively warm compared to as we go up towards that haze layer. It's decreasing with temperature with height, and then as we enter the stratosphere once again, temperatures do increase slightly with height. We once again have a water ice layer, an ammonium hydrosulfide ice layer, and an ammonia ice layer, as was found on Jupiter. Once again, Saturn's atmosphere is changing over time, and through this image sequence you can see that in 2010 it was pretty much devoid of any kind of surface features. By 2011 we start to see some disruptions of that layering. These bands have changed dramatically. So we can see storm systems popping up on Saturn at times and then disappearing again. And also keep in mind that we can look at Saturn in various different types of light. So in the visible type of light, we would see something like this, whereas in the infrared, we might be able to see the banded cloud structures a little more easily here on Saturn. Saturn has one of the weirdest polar features. It has this enormous polar vortex. As you can see, this is kind of the polar region, and it has this kind of polygon shape at the bottom here. And this hexagon is what Saturn is probably most known for, other than its rings. Its planetary atmosphere is very, very wild. So we've got a southern vortex, and we've got the northern vortex on the bottom image here, as you can see. Uranus is also a very similar atmosphere to that of the other Jovian worlds. Keep in mind, Uranus is less dramatic in terms of its features on its surface, and you can see the slight banded layers here. Some storm systems popping up, and this is noticeably once again in the infrared. Here in the visible light spectrum you might see some things as well, but they're less dramatic than you would see on either Jupiter or Saturn, and as you'll see on Neptune as well. So moving on to Neptune, you'll notice that Neptune has a large storm system as well. And this great blue spot here, as you can see, is a pretty dark area, and surrounding it are some other white colored clouds, and this is once again in the visible light spectrum. So we are seeing that Neptune has a significantly more dramatic atmosphere than Uranus does. So thanks for watching Jovian Planets, Atmospheres of the Jovian Planets. If you like this video, please click the like button. If you'd like to learn more, please click subscribe. And if you'd like to get a notification each time I make a video, please click the little bell at the bottom. Thanks again, and have a great rest of your day.